Hello, and welcome to this next session for CKA exam mock exams number 3. So what we're basically going to do is we're going to continue on with the code cloud, and this pattern is going to follow on with the same pattern that we've been creating in the past few sessions. So really what we're going to do is we're going to go into the GitHub repository for the YouTube series here, going to go down to series 2 again for the Kubernetes CKA exam here, and we're going to go down to mock exams and number 3, and this is going to be a series 2.8 recording that will be basically shared out afterwards. So what we're going to do first of all is we're going to come down to question number 1 here. So what I've done is I've gone into Code Cloud for CKA for my package that I've already purchased, and I'm in the mock exam number 3 here. So basically it says create a new service account with the name PV viewer, grant this service account list access to a list for all persistent volumes in the cluster by creating an appropriate cluster role called PV viewer role and a binding called that. Next, create a pod called that and the default namespace. So there's kind of a few tasks here that you can sort of see that we actually have to do. So the first thing is create a new service account with the name PV viewer. So what I'm going to do here is I'm going to go into my notes here and I'm going to create that service account here, and then I'm going to create the cluster role here as it says. So grant this to a cluster role. Yes, okay. So basically, so it says grant this service account. So there's your service account. Um, so there's your service account. So we're going to create a cluster role first, and we're going to give it like a variable of list. So the service account can basically only list out the actual pods or um, required items. So here we're going to actually sort of say that we're going to create the cluster binding. So between the cluster binding is going to have this name with the cluster role, which is the one that we just created here, with the service account, which is here. So this is the one, the cluster role binding, which kind of binds the two of those absolutely together. And here, just kind of in my notes as well, I had actually this this default, because it does sort of says in the default namespace, that one may have to be kind of updated if it did actually ask for you to do it in a different namespace. But right now, you can describe your cluster role and you can get some information about it. But in the interest of time, I'm just going to go ahead and I'm going to create my pod, because it does sort of say that next create a pod called that with the image that. So we're doing that with the service account that. So what we'll do is we will add that service account now into my pod here. So there's no actual nice way to actually from imperatively to actually kind of create your service account name. So really what I actually have to do is I actually have to come down to this. I don't actually need. So here I can just sort of say, I can delete that. I can kind of come in here and I can just put that as back as that. So service account name is under containers. So the service account name will basically be applied to all containers here. And that looks exactly what I've done here. So I'm just going to, in the interest of time, escape out of that, save that, and create my pod here. And then I can basically say, describe my PV viewer here, or describe my pod, or whichever way you kind of prefer to do it. But basically I'm going to describe my pod here. And you should sort of see that, so you can sort of see that the pod name is here and the service account is actually listed here. So, anything in this pod is basically running under that service account. So anything that service account can do, because it's bound back to the role, is anything that this pod can basically do. So this does kind of specify and clarify that first question there. So next thing we want to kind of do is, it says here, list the internal IPs of all nodes in the cluster, save the results to that. The answer should be in the form of that. So basically, here's where it's kind of, a little bit more kind of tricky, because it's just saying the answer should be in the format. So internal IP of control plane, space, internal IP of node in a single line. So really, what kind of specifies this correctly is basically by running this command here, for example. So let me just kind of clear this space here. So it sort of says here, get nodes using JSON format. So basically, get the IP addresses and get the field that's of type of internal IP, that address, and output it to there. So it should be answer should be in the format internal IP of the control plane and internal IP of node 1. So okay, so basically what's happening here is that every single node that it's basically going through, it's using the asterisk here to basically look up every single node here, and then basically for every single node in that list that it retrieves, get the internal IP and just kind of output it to that file. So that's all it's really doing. But really, kind of have a look back at the session for JSON path that we previously did, which would kind of explain a little bit more about that. So let's kind of move on to the next question here. So it says, create a pod called multi-pod with 2 containers. Container 1 should be this, container 2 should be this, environment variables should be this. This is about multi-pod containers. So if I kind of went over to my ChatGPT here, so it said new. So I want to kind of understand a little bit about multi-container pods here. Let's just sort of see what ChatGPT says to me. Kubernetes, the pod is the smallest deployable unit. Okay, multi-container pods are pods that can run multiple containers that work together in a single application or service. So really, what you're trying to do here is demonstrate that you can actually understand and create a multi-pod container to do different specific tasks. So that the multi-container pod container will basically do specific tasks. So the first thing I want to actually do is create, a normal Nginx pod here, because you can't actually create that imperatively from the command line. So create a normal pod here, and what we need to kind of do is actually update that pod. So let's sort of see. I'm going to go back into my VI command here. It's going to take that, and you can sort of see. Let's just clear that all lines in the buffer, and let's just kind of take our final solution here. So the name should be that container 1 basically. So container 1 should be Nginx. It should be of image Nginx, the name alpha. Okay, and then the busy box should be beta, and then that should actually sleep for 4,800 milliseconds. So that looks to be exactly what we require here. So I'm going to, just in the interest of time, I'm going to create and describe it. So you can sort of see that there actually should be 2 containers. So there's one called alpha and there's one called beta. So 2 containers here into our specific pod here. So the next thing I want to kind of do here is I want to go to our question number 4 here. And this says create a pod called that with that image and the security dependencies and permissions set on the actual pod itself. So if I kind of come down here and you look at, I've listed out the security context here, for more information. You could certainly kind of go to that. Actually, I'm just there from the last one, but you can kind of go to that and you can basically sort of see, if you go up in the actual pod here, in the notes here, you could sort of see about how you can kind of set, run as user. But make sure that you actually understand, how to set the run as user the differences between setting it on a pod and setting it on a container itself. Because a pod basically says that if you set it on a pod, it gets for all the containers, and if you set it on a container, it only gets for the individual container. So, permissions very important in any security context. Let's sort of say if we just apply that, and then you can sort of see here I'm basically setting it on the pod because it's not part of a container, but it's basically sort of says create a pod called that with that image and set those. It doesn't specifically say set it on the pod, but because it doesn't say set it on the container, I'm assuming that you're basically setting it on the pod itself. So we're going to save that here, and we're going to come down here, and I'm going to just run that. Okay. So really, you won't see an awful lot of actual difference when you kind of describe your pod here, but there is actually some details here on how to actually go in and verify that the actual pod is running and doing as it basically should in the security context page. But in the interest of time, I'm not going to do that too much. So let's kind of go on to question 5 here. Question 5, we can sort of see there's a weight of 14. And we're probably, got 14 minutes left. But obviously in the kind of in the real exam, you would actually have to be typing a lot of this kind of output in the actual recording time. It would just be kind of too long for me to type this out. But let's sort of say question 5 here. It says we've deployed a new pod called that and a service called that. Incoming connections to the service are not working. Troubleshoot and fix it. So this kind of goes back to our ingress controller session that we spoke about before. Create the network policy by the name of that and allows incoming connections to the service over port that. So it really kind of does come back to the ingress controller here. So if we go back to session series 2 and go back to session 2.21 and 2.22, there's an accompanying video with that as well. But that would definitely give you more information about ingress controllers. So if I just kind of search ingress, okay, so we're kind of back to that kind of question now. So really what I want to do is I want to sort of say describe my service first of all, which is kind of good practice just to actually kind of describe your service and just trying to understand a little bit about the service. And again, I know the time, it's kind of critical in your actual exam, but there is some commands that you will actually have to run, so but basically says we have deployed a pod called that and a service called that. Incoming connections to it are now working. Create a security policy by the name of that. So here we're going to basically create a little temporary pod here that's basically going to be to test the connection. So really what should actually happen is if I curl that service now, it's probably going to time out because I don't actually sort of see any response kind of coming back from that. So what you're really having to do is kind of say right now, do we actually have any security policies? Because one thing that may kind of happen as well is that the security policy is there, but it's just the network policy is just not working as expected. So right now I can only still see like a default deny. So what I'm going to do now is I'm going to create a kind of a new security policy here. I'm going to say go into that. I'm going to take this node first, and you can sort of see that so the name should be for the new ingress policy. It should be basically that name in the default namespace because there's no namespace that's been specified. So we're just going to assume it's the default. Make it matching on this this label. And probably it'd be a good idea to also kind of check that the actual labels are correct in this case because network policies is it's all about labels. It's all kind of related to labels. So kind of labels is the magic sauce here. But the policy type here that you want to get is for ingress and for port 80 and it's TCP. So that looks to be what we would need here. So if I just sort of create that now. and definitely have a look back at that session where we kind of go into this kind of with a few different examples. This this example just basically kind of asks you to kind of create the basic network policy for ingress. But definitely have a look back. So if you sort of see now you can sort of see when we kind of went into our temporary pod here, you can sort of see that when we actually curl the service, we can now get a response from the actual pod where previously, it was basically timing out. There was nothing coming back here. So that also looks kind of good. So let's sort of say that is complete. Let's go into question 6. And this is where it says, take the worker node that to be unscheduled. Once done, create a pod called that. And ensure workloads are not scheduled on this worker node. Finally, create a new pod called that and image that to tolerate with toleration to be scheduled. So, this is where it's one of those things with the taints and tolerations that, you really have to kind of look into it an awful lot more. So if I kind of go into chat here and I went to kind of Kubernetes, I said tolerations here, Kubernetes tolerations, the taints are a little bit more kind of straightforward because all you're essentially doing is kind of spraying the pod or marking the pod to sort of say, you can not schedule any information, but the tolerations get a little bit more kind of complicated. So this is taking a little bit. I notice it's taking a little bit kind of slower to kind of respond to my query. But what I'm going to do is just in the interest of actual time here, I'm going to continue on with the actual question here. So the first thing it sort of said was taint the worker to be unscheduled. So first thing I'm going to actually do is clear. Then you're going to kind of taint it to be unscheduled here. Once done, create a pod called dev. So I'm going to create this dev pod here. And again, I don't run through every single command here just in the interest of time because it doesn't make any sense for people to be constantly just watching every single command here for 3 hours. But basically I can sort of see that, my new pod dev Redis is also up and running here. It's up and running 8 seconds. So now I'm going to go in and I'm going to create my prod Redis here. And I'm going to say that. So I'm going to go in here. And what I need to do is I actually need to add a toleration here. So what I'm basically going to do here is I'm going to just basically create my pod, which is prod Redis, which is exactly what we kind of had before. And then the tolerations is what I've actually added here. So it sort of says, the toleration should be scheduled on node 01. So the type, first of all, the environment type here is the key. The value is the production operator is equal, and the effect is no schedule. Now here, just want to kind of make sure that. Okay, so here I can sort of see that I may have forgotten. It sort of says it should be scheduled, toleration to be scheduled on node 01. I may have to sort of say mark this pod to be only run on 01, but I'll kind of recheck that because I think that's new, or certainly I didn't notice that one before. But what we'll do is we'll kind of run it now anyway, right now, because I do sort of see it running on control plane here. So we can sort of say we'll probably need to check that. So that's something to be kind of checked. But I'm going to check it, in a few moments. I'm just going to kind of let it kind of run right now for the moment, just to see if it's basically running. So it's definitely running, and it's definitely on node 01. Now you can actually schedule a pod. It'll probably be better because the actual question sort of says, it should be scheduled on node 01. So we'll kind of maybe just see if we can kind of improve that question in a few moments. But right now we basically satisfied the actual question because we've created the actual the toleration here. So the only thing we've just kind of a query on that to make sure that we always schedule it basically, because you can set a pod to always run on a specific node. You can do that as well. So right now we may be just kind of lucky that it actually got onto node 1. So maybe a better way to actually do it is actually to make sure that we always kind of schedule onto that specific pod. But for now, we'll kind of move on. And what we'll sort of say here is create a pod called HR in the HR namespace belonging to production environment to Frontier. The name of the namespace, use the appropriate labels, and create all the required objects if it does not exist in the system already. So here you're really kind of just creating, first of all, a HR namespace. So that itself is, hopefully a kind of a few kind of easy points. But so it says create a pod called HR pod in the HR namespace. So we have this HR namespace now belonging to the production environment and the Frontier. So really, this is where this kind of this labeling comes in, because you can actually have multiple labels. So let me just copy this in here first of all. But basically, what we're going to do here is we're going to create a pod here called HR pod, and then we're going to use the Redis image as it says. Then the labels that we're going to mark that pod with is going to be environment is equal production and tier is equal to front end. Now, in this kind of case, you do also need the kind of the equals. So that's a kind of little trick that sort of says, if I'm adding a label, you don't like normally kind of label inside the YAML is kind of like tier colon. So it might be kind of look like kind of tier colon front end inside of the actual YAML. But when you're actually creating it, you actually have to use your equals in your front end like that. So when you're actually creating it inside the imperative method that we're using here. So I'm going to create that, and you can sort of see that's already been created now. Probably HR pod, so I can sort of say, go back to my queue here, and if I sort of say, do I have actually, let's set an alias here, kubectl. Okay, get pods. So I can see that my HR pod is not there because it's in the namespace HR. So I need to do -n for namespace HR. And I can actually sort of see there's an error image pull. It doesn't like what we did there, and I think I know why. So I think I have a typo. So if I sort of say, probably the best thing to actually do is, in this case, is probably delete the pod HR. Well, actually, let's describe it first. Let's kind of describe pod HR pod in the namespace HR. So let's sort of see if we can kind of figure this out. So basically, it says it doesn't actually have yeah, it doesn't. It basically sort of says that the Docker library Redis Alpine was not found. So it does look like it's kind of the way we kind of created it. So what I'll do is I'll leave that, and I'll just sort of say delete pod HR namespace. And you can do just you can actually do dash force to kind of force the pod. That obviously kind of fails because we don't actually have the pod anymore, but you can actually kind of force the pod to be deleted in the exam itself to kind of save a little bit of time. So if I go back to my create Alpine, it looks like I do have a typo actually in my name. So that, and that type of thing can also kind of happen in the exam, but like I sort of said before, try and stay calm in the exam. like in this case, the best thing to kind of do is, because I knew I just created the pod, so I knew it wasn't related to a service or anything. But basically, I just described the pod again, and really, so the first thing I kind of did here was I kind of get the pods, and I could sort of see, well, there's some image issue. Then if I describe the pod, I can sort of see a little bit more kind of detail about, it's basically sort of saying that it doesn't know what Redis Alpine is, you know. But I'm going to recreate the pod. I'm going to get pods again in my HR namespace, and then you can sort of see that now it's actually in the running state of 5 seconds. So it does actually look like, my notes also have a little fix that I need to fix here. There's a little update that I shouldn't have a H in there, which is going to happen. And now if we're going to go down to the next kind of question here, because that's question, we can go down to kind of question 8, and it says a kubeconfig file called superkubeman has been created on the road. There's something wrong with it. Troubleshoot and fix it. So really, I'm going to come to here. I'm going to get nodes. So let's sort of see. So the nodes sort of say as kubeconfig to use the specific kubeconfig file here. So the first thing I want to actually sort of do is sort of say, first thing I want to sort of do here is sort of say, try and allow, actually it looks like a kubeconfig file called superconfig, that's right, has been created on root CKA. So I need to update this. CKA root. Okay, so let's just kind of make sure that I update the actual nodes as well, because it says CKA root. Okay, so I can sort of see here when I actually run the file here, it says there's, couldn't get the current server API, current list, and basically it's just looking like a kind of timeout for the control plane of 999. Now that does not look right to me, but let's, say that right now what we've done is we've used the super kube admin, and you'll sort of see an error that the connection was refused. So then we're sort of saying, okay, so let's sort of say if we kind of get our if we try to get our nodes here, it also sort of says the same thing. So anytime that you're basically using this config file here, you're getting this kind of timeout error. So there's certainly 100% something wrong with this file. So what we want to do is we want to cut this file here. So all I've kind of done here is I've just kind of cutting the kind of super config file here. You can sort of see that up here, I'm sure we have 9999, which we do, which the server name is actually wrong. So what we want to do here is we want to get the actual correct port that it's actually running on. So we're going to, let's sort of see if we can cut the existing one. So we can cut the existing one. And when we cut the existing config file, we can sort of see that the actual port is 6443. So the server line that came back that was found, because we grep for server, the server line that came back was basically 6443. So what we actually have to do then is we now know that we actually have no server running at 999, but we also have it running at 6443. So we need to go in and to our file, to our config file. Some people will do this kind of in various ways, but during the exam, you'll only have kind of VI, so you won't have, Notepad to be using in a kind of easy manner. I'm not sure if there's an actual Notepad kind of on the actual interface that you can kind of use and then kind of paste it back in. but I don't know how that would basically affect the kind of overall kind of pasting of the file. So VI definitely in that case is the kind of quickest way. And then if we kind of come back to our kind of question here, because now we've just updated our super kubeadmin file, and if we kind of try and get our nodes now, with the super kubeadmin config file, we can sort of see that like the control plane node 101, that's all kind of coming back now. That's just because we basically applied that fix to the server file to be the correct port number. So that looks to be good. So let's kind of move on. And again, I mean, as the kind of next or the last question is basically kind of loading up, really kind of what you can also do is, you can sort of go back to ChatGPT here and so say Kubernetes config files. So Kubernetes uses config files. What I think I'm just going to specifically search for is kubeconfig. Stop generating. So I'm going to say Kubernetes kubeconfig. So kubeconfig file is used by Kubernetes command line tool kubectl to configure access to Kubernetes cluster. The kubeconfig file contains information about the cluster, the user context. So if you've ever actually, cat out one of these kind of files, so let's sort of say if we rerun this file and you kind of cat out this file, you can sort of see that now this is probably a kind of a lot smaller one because it's meant to be kind of, a small one, but you can sort of see there's information here about the actual cluster here, and then you can actually sort of see in the actual context, there's actually, information about the actual context. And then there's actually user kind of information about, the certificate information that's config file is basically got configured. So you've kind of got kind of a few different sections going on with the config file. So as it sort of says here, the config file contains information about the cluster, the user, and the context of the user's interaction with the cluster. So do definitely kind of take some time to kind of study a little bit about that because it does seem to be quite a popular choice for your own working environment. So let's sort of clear this 1 second. And it's going to go to our last question, which has a kind of weight of 14. And really, I mean, you'd be kind of looking at sort of saying 19 minutes left. But in reality, you wouldn't really have, we wouldn't really have 19 minutes left. But again, this environment, this kind of mock exam environment is just really for trying to understand and learn a little bit better about the environments and trying to kind of test it so to see how we can kind of find information kind of quicker, and so we will get kind of faster and faster and faster, of these using these environments. But the last kind of question here also sort of states, well, we've created a new deployment called Nginx Deploy, scale the deployment. This is something we've kind of sort of seen quite a few times now. So really kind of, the first thing we actually probably do is also kind of make sure that we can actually sort of see, we can get our deployment. So we can sort of see we've got an Nginx deployment. We can kind of scale that deployment to 3 replicas here. So you can sort of see now, if I go back to my get deployment, you can sort of see that, okay, so only one is ready. So only one pod is actually ready right now, but kind of after time, you'll sort of see that, there will be kind of other 3 ready. So this one sort of says there's one up to date and there's one available, but really if you kind of keep continuing to kind of watch that deployment, you will actually sort of see the scale. Now in reality, what the kind of question here is saying, we've created a new deployment called Nginx Deploy. Scale the deployment to 3, but has the actual replica scaled? And you can sort of see in this case, well, actually, even after a certain amount of minutes, it actually hasn't scaled, right? So there's something kind of wrong with that. So really, you know, it says here, the next logical step is to check here to sort of see if there's no scaling going on, because here you can sort of see that the controller manager is actually controlling the scaling here. And you can sort of see that it's got an image back off. So everything else here is basically running in a running state. So this is your going back to your kind of architecture of your system, um, of your Kubernetes. But when you get the kind of pods in the kube system namespace, which is where Kubernetes places all of its infrastructure pods, you can basically sort of see that this controller manager actually has it actually has an issue here, because it looks like there's a kind of one in here when it actually should be controller. So if you kind of go back to your your manifests, because that's where all of our um, static files are kept, and we just kind of list out so to see what we kind of have here. What we're going to do is you can sort of see that there is a controller file here, and we're going to vi that controller file here, and you can sort of see that the name looks to be kind of it looks to be number one. So basically, somebody has updated this file. Let's pretend, that basically somebody has actually updated this file, kube controller manager, and they basically misspelled this kind of name here. So you can sort of see it's incorrectly spelled. Now, a nice way to kind of do this, you could actually VI the file and kind of go down and search for every single instance of that one for the L that's meant to be an L. But really, the kind of a nice way to kind of do this is if you actually do, and this is something you definitely should be doing kind of into the exam as well. But if I kind of come out of that for 1 second, so I'm going to make sure that I basically, if I do a grep controller, so we know that that's the incorrect word, and we do a grep on the file, so we know that that's the file that we're basically looking at, and then we do a wc-l, that will basically give me a count of all the places or all the occurrences that that word controller with the incorrectly spelled controller is place. So it's actually in 5 places. So, definitely 100% learn this little, so it's a pipe wc-l, learn that command for the actual exam, because, it's definitely a way to kind of help. So if you do wc, you sort of see, it actually kind of tells you that there is actually 5. But if you kind of do it -l, it just kind of gives you the actual the occurrences, the number of occurrences that's basically on. So what we want to do here is another great command here coming from the kind of Linux side is if you kind of seed. So if you seed your kube controller, so this is the word that you're going to, or this is the phrase or the words that you're going to search for, and this is what you want to replace it with, and this is the file that you want to replace it in. And if you put the -i, it will replace all occurrences of that in with that in that file. So now if you kind of rerun your grep controller here, -l here, you can sort of see that now I have 0 occurrences. I actually have 0 occurrences. Now, if I kind of go back now and I sort of say, so let me sort of see if my pod has come back up. Well, let's sort of see if my controller pod has come back up first of all. It's going to go back in here. I can actually sort of see that now that now the controller is actually running. Now it's actually 34 seconds and it's actually in running state, which basically means that my deployment here should actually also be in a running state now. And it should have, you see now it's basically scaled now to 3. So, if I was to scale now, because the controller manager is also working, the scaling is also working. So that looks to be that question. So we've created that, scale it to 3, troubleshoot and fixed issue. Yes. So what I'm going to do now is just actually end exam. Are you sure you want to end this exam? Yes. And let's sort of see how we did. And again, the point of don't be kind of really kind of hard on yourself. It's you'll get faster and get quicker at every kind of run that you kind of do. Now this case is like 100%. So I think we kind of had a query about whether we should actually schedule that on schedule one of the actual pods on the Pacific node. So that's maybe something we'll kind of look into for the next run. But right now, I mean, the 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 test itself came back as 100%. So the actual solutions are all working. So I will see you in the next session. Thank you.